Hello students, yesterday we discussed about the representation of alpha decay, beta decay, gamma decay. Then after we discussed the loss of radioactive disintegration, right? So in today the plan of my talk is as follows: decay constant, half life of the radioactive substance, and the main life, relation between half life and main life. Let us see one by one. So now, according to the law of disintegration, yes, the what is the law of radioactive decay? The rate of decay or disintegration dN by dt is directly proportional to the number of atoms present at that instant. dN by dt is equal to constant minus lambda n, where lambda is called decay constant. Okay, so from this we obtain the formula n is equal n0 e power minus lambda t. This is the exponential law, right? So here, if t is equals to 1 by lambda substituted, then what we get, n is equal n0 e power minus lambda into 1 by lambda, right? Then n is equal n0 into e power minus 1 equal to n0 by e. So when the time t is equal to 1 by lambda, then we are getting n is equal to n0 by e, right? So this is the time taken to reduce the number of radioactive nuclei to n0 by e, to reduce to n0 by e. So therefore, the time duration lambda is equal to 1 by t. It is a reciprocal of the time. In the time duration, the number of radioactive nuclei reduced to n0 by e can be defined as the decay constant. Lambda is the characteristic of the radioactive substance. It depends on nature of the material. Therefore, different radioactive elements will have the different lambda values. Right. Now, what is the half-life of radioactive substance? Half-life half-life of radioactive substance. Radioactive substance. Let us see. We have the exponential law of radioactive substance. N is equal to n0 e power minus lambda t, right? If n is equal to n0, then the time taken, say t is equal to t off. Substituting that, where n0 by 2, n equal to n0 by 2, that equal to n0 e power minus lambda into t off. N0 n0 cancel. 1 by 2 is equal e power minus lambda t off. So you can write 2 is equal e power lambda into t power of, taking logarithm, natural logarithm both sides, ln 2 base e equal to lambda t off, right? Therefore, the t off can be written as that equal ln 2 base e by lambda. This is the expression for half-life of the radioactive substance. So from this we can define the half-life. So how we are taken, T off is nothing but the time taken to reduce the given number of radioactive nuclei to the off. So the time interval in which the given amount of substance reduced to off, the given number of radioactive nuclei reduced to off is called as the off period. Its formula T off is equal to log 2 base E by lambda. Expressing this in terms of log 2 base 10, you can write 2.303 log 2 base 10 by lambda equal to 2.303, this value 0.3010 log 2 value by lambda equal to 0.693 by lambda. Therefore, half life T off is equal 0.693 by lambda, right? From this it is very clear lambda and T off are inversely proportional relation. Therefore, since lambda is inversely proportional to half life of the radioactive substance, if the lambda is more, T off will be less and vice versa. The dimensions of lambda is second in the T inverse units second inverse. Figured half life of radioactive substance T off is equal to ln2 base E by lambda, that equal to 0.693 by lambda. Okay, this is the formula for half life of the radioactive substance. Now we can represent this in the graph. Suppose if the graph is drawn n by n0 taken on y-axis, the time taken x-axis, the graph will be like this. This is at t is equal to 0, n equal to at t is equal to 0, that is when the integration, when the this disintegration is started, that is at the start of disintegration or decay t equal to 0, we have the number of undecayed radioactive nuclei n equal to n0. Then n by n0 equals to what? 1. So this is 1, right? According to our definition, n is equal to n0 by 2. The time taken for the half life, that n equal n0 by 2. Then n by n0 equal to 1 by 2. So you take 0.5 value. Then its corresponding x coordinate represents the half life of the radioactive substance. The same thing you can represent the graph like this also. How? If you take n value on y-axis, t value on x-axis, then same the graph is like this. Here, according to the law of disintegration, dn by dt is equal to minus lambda n, or n equal to n0 e power minus lambda t. The number of radioactive nuclei are decreasing with increase of the time. Their disintegration takes place exponentially. The number of atoms is reducing exponentially with increase of time. This is very clear from this expression. So this is n equal to n0, because at t is equal to 0, we have the number of undecayed radioactive nuclei, how much? N equal to n0. So then after the half-life period, the number of undecayed atoms becomes to n0 by 2, becomes off. Initially we have n0. The time required to reduce n0 by 2, that is the half-life. So n0 by 2, then the corresponding time represents it is half-life, T off or capital T. So now again to reduce n0 by 4, half of this, then another half-life time taken, this represents 2t. Again to reduce half of this one, that is n0 by 8, again one more half lifetime period taken, therefore this represents 3t. So like this you can understand with the graph. This is about half-life, right? So what we are discussing, the parameters of the radioactive substances. That is first thing we discuss the exponential law, that is mathematical expression n equal to n0 e power minus lambda t. Then after we discuss the half-life. For that expression is T off is equal to ln2 base E by lambda, that equal to 0.693 by lambda, and its graphical representation also we covered. Now the third parameter of the radioactive substance is mean life. Mean life is also called as average life. It is denoted as with the letter tau. What is the mean life? Yes, it is defined as the ratio of sum of lifetimes of all the radioactive atoms to the total number of such atoms. That's why it is written as tau is equal to total lifetime of all atoms by divided by total number of atoms. Total number of atoms. What I am saying, mean life tau is equal to the ratio of total lifetime of all atoms or nuclei divided by total number of atoms, right? So let us suppose that n0 is the total number of atoms, then total lifetime of dn atoms is equal to t into dn. T into dn. Why? Because since the dn atoms disintegrate, dn atoms disintegrate between the time t and t plus dt, right? Hence each of these dn atoms have survived for time t before decaying. Therefore total lifetime total lifetime of dn atoms is equal to t into dn. Let me repeat. dn atoms represents what? The number of atoms decayed between the time interval t and t plus dt. So then dn atoms are survived before the time t. That's why the total lifetime of dn atoms is given by t into dn. Therefore, the total lifetime of all atoms we can write it as integral 0 to n0 t into dn, right? The total lifetime of all atoms is equal to integral of 0 to n0 t into dn. Say this is equation 1, right? Now what we are writing, total lifetime of all atoms is equal integral 0 to n0 t into dn. We are taking this equation 1, but we have the exponential law n is equal n0 e power minus lambda t. So then differentiating both sides with respect to dn is equal to what we get, minus lambda n0 e power minus lambda t dt. Substituting that, then you will get t total lifetime of all atoms is equal integral limits changes infinity to 0 minus lambda n0 e power minus lambda t dt. Okay. So now constant lambda n0 right outside, minus lambda n0 integral infinity to 0 e power minus lambda t dt. Okay. Say this is equation 2. Integrating by parts, we get total lifetime of all atoms is equal lambda n0 into lambda n0 into, oh, see here, by changing the integration you can write it as integral lambda n0 into integral of 0 to infinity e power minus lambda t dt. Say this is equation 2. Don't confuse. Here what we got, minus lambda n0 integral infinity to 0 e power minus lambda t dt. I am changing the limits. Lambda n0, then we get negative sign, minus and minus gets plus, integral 0 to infinity e power minus lambda t dt. That is called lambda n0. So integrating by parts, then what we get, e power minus lambda t by minus lambda limits 0 to infinity minus integral of 0 to infinity e power minus lambda t dt, right? Right? So total lifetime of all atoms, so what we got? Lambda n 0 power minus lambda t by minus lambda 0 to infinity minus integral 0 to infinity this one. Then applying the limits, that equals to total lifetime is equal lambda and 0, applying the limits to upper limit and lower limit. Here you will get 0, right? The second term minus lambda and 0 into integral 0 to infinity e power minus lambda t dt. Okay, so that equals to minus lambda and 0 minus lambda and 0. It is integration of e power minus lambda t, e power minus lambda t by minus lambda, and writing the limits 0 to infinity equal to, right, minus lambda outside, lambda lambda cancel, or minus minus cancel, and 0 e power minus lambda t limits 0 to infinity equals to n 0, applying the limit, first upper limit, minus infinity minus e power 0, e power 0, e power 0. Here e power minus lambda t, somewhere we missed lambda. So where we missed lambda, 1 by lambda t into e power minus yes, here 1 by lambda into e power minus lambda t by minus lambda plus 1 by lambda into this one. Here 1 by lambda is there, 1 by lambda is there, lambda is there. Here also lambda, lambda. Okay. Now, so that equal to n0 by lambda. This is 0 minus 1, 0 minus 1, a minus sign is there, right, equals to n0 by lambda. Okay, so then total lifetime by n0 is equal to, you will get 1 by lambda. But according to our definition, the ratio of this, the ratio of total lifetime of all nuclei to the total number of atoms is nothing but mean life. We are denoting with the letter tau. So tau is equal to total lifetime by n0, that equals to, finally we got 1 by lambda. Therefore, the final expression for mean life or average life of the radioactive substance equal to 1 by lambda. Or we can define it in other words as, it is the reciprocal of decay constant. It is the reciprocal of disintegration constant, nothing but mean life. Now, the next concept we are going is relation between, what is the relation between half-life and mean life of radioactive substance. Yes. So just now we derived that mean life tau is equal to 1 by lambda. Okay. Half-life T off is equal, what we have, it is 0.693 by lambda. So from these two equations, simply we can write T off is equals to 0.693 into 1 by lambda, that is tau. Or tau is equal T off divided by 0.693, you will get 1.44 T off. Therefore, mean life is equal 1.44 times to that of its off life. This represents the relation between mean life and off life of radioactive substance. So, in this class, what we discussed, the parameters of the radioactive substances we discussed. The first, what is the disintegration constant? We defined that one. Then, We discussed about the off-life and its formula and graphical representation. Then we derived the expression for mean life or average life. So lastly, we discussed the relation between off-life and mean life of the radioactive substance. Thank you.